So on week 7, numbers 15, 16, 17, and 18. Talking about parallel and perpendicular lines or neither. When you're given two equations, y equals, say, 3x minus 4, and y equals 3x plus 10. The key thing to figure out if you have parallel, perpendicular lines, or neither. Well, parallel lines mean they never touch each other. Perpendicular means they intersect at right angles, and neither means they just go out crazy and they just intersect in no particular rhyme or reason. The thing that influences these parallel, perpendicular, and neither is the slope. Slope is key for this. So in this problem, you got to figure out what the slope is. What is the end in each one of these equations? And if you look, these are lined up really nicely. So you figure out, I have both slope for this first line is 3, slope for this bottom one is 3, so the slopes are the same. So if slopes are same, the exact same number, this means they are parallel. If they are opposite, so one's positive, one's negative, and reciprocal fractions, this means they are perpendicular. Perpendicular, you have to have a positive slope. Well, it helps to have a positive and then a negative, and then they'll be opposite. So if you have y equals 1/4 x plus 2 and y equals negative 4x plus 7, well, these may not look like it, but first thing we check for is they are, first of all, this is one key thing, and two, they are opposite. Well, here's your slope for this one. It's positive, this one's negative, so that's the opposite. The reciprocal means that you have a fraction like 2/3 and then you flipped it upside down, 3/2. These are reciprocal fractions. So this means reciprocal. The fractions are flip-flopped. On first look, this doesn't look like reciprocal, but it is because I need to make it a fraction. Anytime I do, I make the fraction bar and put it over 1. So they're opposite, positive, negative, and then 1/4 and 4/1. So these two lines are perpendicular. Now, if the slopes are different and they're not opposite reciprocals, then they are not parallel and they are not perpendicular. So problems like 15 and 16 specifically. If you have 3x plus 2y equals 6, and then you have something like y plus 3 equals negative 5x. Okay, first thing you gotta do is get the y by itself. I want the y equals mx plus b form, so I'm gonna subtract 3x. But I'm not subtracting it from 6, they're not like terms. So 2y equals 6 minus 3x. By 2 divided 2 divided 2. I have y equals 3 minus 3 halves x. So I can look at this and say, here's the x, here's the slope of this one. For this one, I just subtract 3 and I get y equals negative 5x minus 3. Here's the slope of this one. They're not the same, they're not opposite reciprocal, so these two are neither parallel or opposite reciprocals. So try that sort of stuff for numbers 15 and 16. On 17, find the line parallel to this one, plus y equals 9, and through point 2, negative 3. So first thing I need to do is figure out the slope. So I need to get the y by itself. So I'm going to move this by minus 4x minus 4x. Y equals 9 minus 4x. Now, since I have y by itself, I can figure out, here's my slope because it's next to the x. So I have slope of negative 4, and now I have the point 2, negative 3. Now you need to go back to numbers like 10 and 11 and go through this whole process to find the line. So that's your charge. Find the line like numbers 10 and 11. So plug in the m, plug in the x1, plug in the y1, do some distributing and solve it. Number 18 says perpendicular. Now remember, perpendicular, they have to be opposite, like positive, negative sign, and they have to be reciprocal, so the flip fraction. So if you're given y equals negative 1/2 x plus 3, I'm worried about the slope. I need to be perpendicular to this and through this. So first thing, you got to figure out the slope here. Well, if it was parallel, I wouldn't have to do anything with it, but I want perpendicular. So I need to make, from a negative, I need to make it a positive. So it's positive. And then instead of 1 over 2, it's going to be 2 over 1, or slope is positive 2. Now you go back and use this like number 10 and 11. In the end, I want to see y equals what's over on that side. Good luck finishing that.